This video is going to walk us through parallel lines and how to find the equations of parallel lines given different information. So let's review first, what does slope mean, what does y-intercept mean, and what does slope-intercept form look like for a linear function. This was all stuff that we looked at first semester. So slope, we use the letter M when we're talking about slope. Slope is our rise over run when we're looking at our graph. It's our change in y divided by our change in x. So the formula that you guys have on your formula sheet is y2 minus y1 over x2 minus x1. So as long as I have 2 points, I am then going to be able to find the slope, okay? And if you have a graph, again, you can just use rise over run to find the slope. Y-intercept is wherever the graph or the line hits the y-axis. So this is the y-axis. So y-intercept would be any point that's on that line, wherever my line is. If this is my line, then this would be my y-intercept. Okay, and it's written as a coordinate. The x value is always 0. So it's 0, and then we use b for the y-intercept. So wherever the x value is equal to 0, that's your y-intercept. So if you're looking at a table and you can't figure out which value is your y-intercept, it's going to be wherever x is equal to 0. So then the slope-intercept form is y equals mx plus b. Sometimes we're going to see this in function notation. So instead of y, we would use f of x or k of x or g of x or any kind of other function notation. But y equals mx plus b is our slope-intercept form. All right, so still in a little bit of a review mode here. If I want to write the equation of a line and it's a linear function, I need 2 pieces of information. I need my slope and I need my y-intercept. So to find the slope, if you're looking at a graph, we can just count. If we're not looking at a graph, we can use the formula y2 minus y1 over x sub 2 minus x sub 1. Okay, so -4 is an x value, -6 is a y, 0 is an x, and 10 is a y value. The order doesn't matter as long as you stay consistent. So if you are going to make the 10 y sub 2, then the 0 needs to be x sub 2. We need to make sure that those points stay consistent between the x and the y. So if I start with 10, I would do 10 minus a -6 divided by 0 minus a -4. So be really careful when you're subtracting a negative. That changes it to addition. You can also utilize your Desmos calculator and type this in, and it will give you the slope. Be careful if it gives you a decimal. We're always writing the slope as a fraction because it represents, again, our rise over our run. So this would become plus, which is 16. 0 plus 4 is 4, and 16 divided by 4 is 4. So my slope is 4. Then for the y-intercept, remember that the y-intercept is where the graph intersects the y-axis, but it's also when x is 0, which is this point that it gave us right here. So if I know that the line is passing through that point, then I know that the y-intercept is 0, 10. And so that means that this is my b and 4 is my m. So now we can write the equation in slope-intercept form as y equals 4x plus 10. Example 2, similar situation. We need to write the equation given this information. So I need to write the equation of a line that has a slope of -2 and passes through the point -7, 9. So in order to write the equation in slope-intercept, I need the slope, which I have in this case. I don't need to use a formula. The slope is -2. Okay, and then we need b, which is the y-intercept. Now, I don't have that because this point is not the y-intercept. So how do you find the y-intercept if you don't have it? You could definitely use your graphing resources. You could type that point in and you could count the slope going up to left one, up to left one, or down to right one, down to right one until you hit the y-axis. You could do that either on graph paper or on the computer. Algebraically, to be able to find this equation, I can fill in the pieces of information that I know and we can solve for b. So what do I know? I know that the slope, which is m, is -2. So I can substitute -2 in for the m. Well, what else do I know? I also know x and I also know y because of this point. So x is -7 and y is 9. So I can substitute for the y a 9 and I can substitute for the x a -7. I still don't know what b is, but now I can solve this for the value of b. So I would have 9 equals -2 times -7 is 14. And then how do I isolate b and get b by itself? I need to move the 14 to the other side of the equation. Since it is a positive 14, I can move it by subtracting 14 from both sides. And then 9 minus 14 is -5, and that is the value of b. So now for my final answer, writing it in slope-intercept form, my slope is -2, and my y-intercept is -5. So those examples should have been very basic. That was a review of being able to write an equation in y equals mx plus b in slope-intercept form. So now we're going to look at, okay, how do I write something in slope-intercept form, but then also write the equation of a line that is parallel to the first one? So remember that parallel lines are two lines in the same plane that never intersect each other, okay? So even if two lines on a given graph that you are looking don't intersect each other, that doesn't mean that they won't eventually intersect each other. So in order to be parallel, they will never intersect. All right, and this is the symbol for parallel. So whenever you see those two lines next to each other, that means parallel. If two lines are parallel, then they will have the same slope. They will be going in the same direction, rise over run, and then they will never ever intersect each other. So that piece of information is going to be helpful. If I know the slope of one line, then I know the slope of the line parallel to it because it will always have the same slope. So for our first example, find and use the slopes to determine if line A is parallel to line B. So in order to be parallel, they must have the same slope. So what is the slope of line A? Well, I'm given 2 points on line A. So for line A, I would need to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I have xy, xy. Again, the order doesn't matter as long as you stay consistent with your order. So if I start with -1 minus -9, then I would need to start with -5 as x sub 2 minus -3. So -1 minus -9 is 8. -5 minus -3 is -2, and then we simplify that. So our slope for line A is -4. All right, now to see if these two lines are parallel, I need to determine if they have the same slope. Line B is already given to us in slope-intercept form, so I already know that the slope is 4. Now, are they parallel? The question is this slope the same as this slope? Even though they're both a 4, one is positive and one is negative, which is very different. That means that the lines will be going in different directions. which means that they will eventually intersect each other. So no, these lines are not parallel. So example 4, write the equation for the line that is parallel to y equals 1/2 x plus 7 and passes through the point 4, 1. Okay, so 2 pieces of information you need always to write the equation of the line is the slope and the y-intercept. I have the slope is 1/2. If I'm writing the equation for a line parallel, it's going to have the same slope. So the slope of the parallel line would still be 1/2, okay? And I'm going to use this symbol for parallel. So that's my parallel line. So now for the y-intercept. I don't have the y-intercept. I have another point that the line is passing through, but I don't have where it crosses the y-axis. So how do I find it? I'm going to use the equation similar to how we did in the second example at the beginning of the notes. I'm going to use y equals mx plus b and plug in the information that I know. I know that the slope is 1/2. I know that a value of y that the graph passes through is this point. So the value of y would be 1 and x would be 4. That point is a solution because the line passes through it, and I can use that to solve for b. So 1/2 times 4 is 2. Then to get b by itself, I would subtract the 2 to the other side of the equation. So 1 minus 2 is -1, and that is my y-intercept. Now, you can always check this. You could type both into Desmos graphing calculator. You could make sure that they're parallel. You can also type this equation in and make sure that it passes through the point 4, 1. But my final equation would be y equals mx plus b, so 1/2 x minus 1. Example 5, determine the equation of the line parallel to the line graph below that passes through the point 15, 7. So the first thing that I need to figure out is what the slope of this line is. If I'm writing the equation of a line that is parallel to this one, then it will have the exact same slope. So once I find the slope of this line, that will be the slope of the equation that I am writing. Okay, so how do you find slope when you're looking at a graph? You could pick 2 points and use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, but you can also just count. Slope is rise over run. Where you have to be careful is that you're seeing points that are hitting precisely at whole numbers because we're choosing to count. So a lot of times students tend to just go straight for the x and the y-intercept, which is fine if those are there, but a lot of times that means that that fraction will reduce and you're counting a much bigger number than you need to. So this would be up 3 and then over 9. If you keep looking for more points where it hits nicely, it hits at 3, -2, and it also hits here at 6, -1. So then we're counting up 1 over 3, up 1 over 3, up 1 over 3. So a couple mistakes that students make. They don't reduce, so they would leave it as 3 over 9 instead of reducing to 1 over 3, but then also be careful of your signs. We are going up, which is positive, and also to the right, which is positive. So therefore, I have a positive slope. If you go down, that's negative, but then you're also going left, which is negative. A negative divided by a negative would still yield a positive slope. Okay, so my slope is 1/3. So now I need to determine what the y-intercept is. I have a point, but it is not my y-intercept, so I need to use the slope-intercept form to solve for b. So the y value is 7, m is 1 over 3, x is 15 plus b. Then I solve. So 1/3 times 15 is 5. Subtract 5 from both sides, and we get 2 for the value of b. So our equation in slope-intercept form for the line parallel to the one that is graphed would have the same slope of 1/3 and the y-intercept was positive 2. Example 6, determine the equation of the line parallel to the line graph below that passes through the point 6, negative 7. So again, I need to find the slope first, and my line that's going to be parallel will have the same slope. So we can use the x-intercepts if we want. There's another point in between those. This is going up to left 1, up to left 1, up to left 1. And I would always make sure that whatever you're counting, it continues on. Sometimes it may look like something is the slope or that the point hits really nicely, but then if you continue to count, it doesn't line up with your graph. So if I'm going up 2, but then left 1, that means the 1 would be negative. 2 divided by negative 1 simplifies to be negative 2. So our slope in this case is negative 2. So determine the equation of the line parallel to 6, negative 7. So again, this is not my y-intercept, but I can use it algebraically to find the value of b. So I would substitute in negative 7 equals my slope, which is negative 2, x is 6 plus b. So negative 7 equals negative 12 plus b. Now, every example that we've done, we've taken that constant and we've subtracted it to the left-hand side, but we've done that because it's been a positive number. So in this case, because the 12 is negative, when I want to cancel it out and move it to the other side, I would need to add it. So negative 7 plus 12 is 5, and that would be the value of b. So my equation would be y equals negative 2x plus 5. Now in this example, I want to talk about one other way that we could have found the value of b that is not algebraic. Now sometimes we can't avoid doing algebra. This is an algebra class. We're going to need to know how to solve. So for some of you, it might just be quicker to do it the algebraic way every single time. But if I know that this line is going to pass through the point 6, negative 7, that point is right here. So then if I know that it needs to be parallel, I know it needs to have a slope of negative 2. So up to left 1, up to left 1, up to left 1, and we can keep counting until we hit our y-intercept, which is at 5. So that would be another method for being able to find that y-intercept without plugging into the equation.